Hello students, welcome to LearnGuru Classes. So today we are going to discuss about decimal expansion of rational numbers. So this topic has already been covered in gist in the second lecture. Okay, so now in this class we are going to study decimal expansion in details, types of decimal expansion, how to convert decimal expansion back to fraction. So all these things we are going to study in detail along with some numericals. So with this, let's start the class. So before going into decimal expansion, the thing that strikes our mind is that what are decimals? We know what are decimals, right? We have seen. You can name or you can say the example of decimals, like decimal can be 0.375, 1.628, or 50.333. All these are the examples of decimal. But if somebody asks you how do you define a decimal, what will be your answer? The answer is that a decimal number is any form of number that has two parts. Okay, one is the whole number part, this is decimal. Okay, so one has the whole number part and the other part is the fractional part, and both of them are separated by a dot. So this is the example, or this is the definition of a decimal number. So let's see whether it is satisfying the definition or not. Suppose 0.375. 0, we can call this as a whole number. 0 is a whole number, and 375 is the fractional part, and this part, and this is the dot or the decimal. 0.375 we call. Or let's come to this 1.628. 1 is a whole number and 628 is the fractional part. And 50.3333, yes, 50 is the whole number part and 333 is the fractional part. So this is how we define any decimal number. So there is another way of defining decimal. The way is that any number that can be expressed in the form of p by q, where q is not equal to 0, is also called a decimal. Yes, can you relate to this? If you have studied the definition of rational number, you can say that yes, this definition is matching with the definition of rational number. Rational number also has the definition, any number that can be expressed in the form of p by q, where q is not equal to 0, is called a rational number. So can we say decimal is a rational number? Yes, of course, decimal is a rational number because fraction is a rational number, isn't it? Fraction exists in the form of p by q and q is not equal to 0. So fraction is a rational number, and this fraction can be converted into decimal equivalent. We can convert any fraction to its decimal equivalent. So can we say decimal is a rational number? Yes, decimal is also a rational number. So next topic of discussion is how do we convert any fraction into its equivalent decimal number. Let's see how we can convert any fraction into equivalent decimal expansion. So these are the two fractions. 3 by 8 is a fraction which is a rational number. 2 by 3 is a fraction which is a decimal number. Now, so in this fraction, 3 is the numerator, 8 is the denominator. isn't it? So to the first condition for conversion of a fraction into equivalent decimal expansion is that you have to divide the numerator by the denominator, that is 3 by 8. So what will you do? This. Okay, so here 3 is less than 8, so you cannot continue the division. So for that, what you need to do, you need to put a 0 over here and to place the decimal over here. So 8 3s are 24. 24, so this is 6. Again 6 is less than 8, so again you have to put a 0. So 8 7s are 56. So 4, again 4 is less than 8, again you are putting a 0. So 8 5s are 40. So ultimately the remainder is 0. So here you see, so 0.375. So 0.375 can be written as 0.375. Can I write it as 0.375? So 0 is the whole number part and 3.75 is the fractional part. So you see how easily we can convert any fraction into equivalent decimal expansion. Now let's move on to the next fraction, that is 2 by 3. So 2 by 3, again this is the numerator, this is the denominator. So to convert fraction into equivalent decimal expansion, you have to divide the numerator by the denominator. So what will you do? This is 2. So 2 is less than 3. So you have to put a 0 over here. And here is the point. 3 6 are 18. Again you are getting 2. So again you have to put a 0. 3 6 are 18. So 2, 3 6 are 18. So repeatedly you are getting the remainder as 2. So from that also we can write 0.666666. Okay, let me write up to this. Afterwards I will explain you. So this part we can call it as the whole number part, and this part we can call it as the fractional part. Now, can you point out the difference between these two divisions? Yes, can you find any difference between these two divisions? The difference is that here you are getting the remainder as 0 and here you are not getting the remainder as 0. Means repeatedly one single digit is being repeated and afterwards you are bound to continue the division. Okay, so this is also a decimal expansion and this is also a decimal expansion. So based on these two examples, we can call this particular decimal expansion as what we call it as terminating decimal expansion. What we call it as terminating decimal expansion. And this example, since you are not getting the remainder as 0, we call it as non-terminating decimal expansion. Non-terminating decimal expansion. So terminating decimal expansion, how do you define a terminating decimal expansion? The terminating decimal expansion or terminating decimals are those decimal numbers where the fractional part has finite number of digits and after performing the division you get the remainder as 0. Means the division comes to an end after the remainder is 0. Okay, whereas in non-terminating decimal expansion the fractional part remains, the number of digits are infinite and the there is no scope or there is no chance of becoming the remainder to be 0. Okay, so this is the difference between terminating and non-terminating. Terminate means you are ending the decimal, so and non-terminating means you cannot end or stop the division further. So these are the two basic differences between terminating and non-terminating division. So these two topics also I have discussed in my second lecture. So please refer the second lecture, link will be available here. Okay, so non-terminating decimal expansion are of two types. What are those? Non-terminating and repeating decimal expansion, and non-terminating and non-repeating decimal expansion. Non-repeating decimal expansion. These two, what the examples of non-terminating and non-repeating decimal expansions also we are going to see. But for the time being, non-terminating and repeating, that is what just like this example 0.6666. So here 6 is being repeating. Okay, but in non-terminating and non-repeating means what? The decimal will never end and that no two digits will repeat or a sequence of digits will not repeat. I will show you more examples on non-terminating but repeating decimal expansion. That time it will be clear to you. Okay, so when I have taught you how to recognize a rational number, I have told you that any decimal expansion that can be that are either terminating and non-terminating but repeating are called as rational numbers. So this terminating decimal expansion we will call it as rational number, and non-terminating and repeating decimal expansion also we will be calling it as rational number, but non-terminating and non-repeating are recognized as irrational numbers. So we are going to study these things in detail when we will study irrational numbers. So but for the time being, you just remember that the decimal expansions that are terminating or non-terminating but repeating are recognized as what? Are recognized as rational numbers. Okay, so next we are going to take some examples and let us identify which decimal expansions are terminating and non-terminating but repeating. So this is the question that we are going to discuss, where it is given that determine by division method whether a decimal expansion is terminating or non-terminating but repeating, and determine periodicity if non-repeating. So four problems are given to you. So let's solve one by one. So first is 7 by 8. So to convert it into equivalent decimal expansion, what is required to be done? You are to divide the numerator by the denominator. So 7 by 8, 7. So 7 is less than 8. So you are giving a 0 and you are putting a decimal. So 8 8 ja 64. So you are getting 6. Again 6 is less than 8. So you are putting a 0 over here. 8 7s are 56. So you are getting 4. 4 is again less than 8. So 0. So 8 5s are 40. So you ultimately you are getting the remainder as 0. So what is this decimal expansion? Terminating or non-terminating but repeating? Yes, it is a terminating decimal expansion. It is a terminating decimal expansion. And what is its periodicity? We find periodicity only for non-terminating decimal expansion. Okay, so here we don't need to find out the periodicity, or if anybody asks you what is the periodicity here, since no digits are repeated, periodicity is 0 over here. Some tricky question might be asked in the exam. So here periodicity is 0 since no digits are being repeated and it is a terminating decimal expansion and remainder is 0. So for this we are telling that periodicity is 0 here. Okay, let's move on to the next sum. 8 by 3. So 3 2 ja 6, isn't it? 8 divided by 3. So 3 to 8 is greater than 3. So 3 2 ja 6. You are getting the remainder as 2. So 2 is less than 3. So you are putting a 0 over here and a decimal over here. So 3 6 are 18. Again you are getting the remainder as 2. 2 is less than 3. Again 0. Again 6. 18. 2, 0, 6, 18. So this process of division will continue till infinity. Okay, so you have to stop the decimal expansion, and as it is non-ending, so we are calling it as what? Terminating or non-terminating. This is a terminating non-terminating decimal expansion. So we write it as 2.666, that is written as 2.6 bar. So it is assumed that what? 6 is being repeated. Okay, so this is a non-terminating decimal expansion. I am writing only in small abbreviation, non-terminating decimal expansion. Okay, so what is its periodicity? How will you determine the periodicity of non-terminating decimal expansion? The number, simply the number of digits under the bar will give you the periodicity. So here the periodicity is 1. Since only one digit is under the bar, so we say that the periodicity is 1. If you don't see here, I am writing here periodicity is equal to 1. Okay, so let's move on to the next sum. 2157 by 625. Okay, so this is a long division. Okay, so you have to see. So 625. So 6, here I am doing the rough work. Okay, 625 into if I multiply it with 4, it will be more than 2157. So let me multiply it with 3. 5 3 is 15, 3 2 is 6 7, 6 3 is 18. So you are getting it as 31875. So 2, this is 5 8 8 9 10 11 2. So 282 is less than 625. So you have to put a 0 over here and place the decimal point here. So 625 into 4. If I do it with into 5, then it will be more than 2820. So 625 into 4. So you are getting 5 4s are 20. 4 2 are 8, 9, 10, 6 4 are 24, 24, 25. So 2 5 00. So 0 2 3 0. So 625 into 5, if we do 625 into 5, so 5 5s are 25, 5 2s are 10, 10, 11, 12, 6 5s are 30, 31. So these calculations I am not explaining you, just I am doing by myself. You check it. Okay, 5, this is how much? 8. So 7, this is 0. Okay, so you have, since this is 75 is less than 625, so you have to put a 0 over here. So 625, 625, so you are getting 5 2 1 and 125, so this is 0. So 625 into 2 is 0, 2 to the 4, 5, 6 to the 12. So 1250 is ultimately the remainder. So you are getting the remainder as 0. So this is a long division. So these calculations, try to do it by yourself. Probably you may not, the rough work may not be visible to you. So I urge you to do the division by yourself and match the answer with me. Okay, so the answer is coming since remainder is 0. So this is the required decimal expansion. So what will you call it? This is terminating decimal expansion. This is terminating decimal expansion, and since it is a terminating decimal expansion, periodicity is 0 over here. Okay, so let's move on to the next sum. 2 by 11. So 2 by 11. So 2 is less than 11. So what will I do? This is 11 ones are 11, 9 0, 11 8s are 88, 2 0, 11 ones are 11, again 9 0, 11 8s are 88, again 2 0 11. So what can you say? 0.18181, again it will be this. So we can say that this is a non-terminating decimal expansion, since remainder will never come to 0 and the process of division will continue. So this is a non-terminating decimal expansion. So 0.1818. So this sequence, this is the sequence. 18 is the sequence of digits that are being repeated. So just we can write it as 0.18 bar. Okay, so how many digits are under the bar? 2 digits are under the bar. And what will be the periodicity over here? Periodicity will be equal to 2. Periodicity is 2 over here. So see here, what is the difference? This is also a non-terminating decimal expansion. This is also a non-terminating decimal expansion. Difference is that here only one digit is being repeated. 2.6666, only one digit is being repeated, and here a sequence of digits are being repeated. Okay, so this we call it also a non-terminating decimal expansion, repeating decimal expansion. Here sequence of digit 0.18, probably it may be like this. Some example may be 0.325, 325, 325, in this way. So these serial digits are being repeated, sequence of digits are being repeated. So this is also an example of non-terminating but repeating decimal expansion. Okay, so I think these things are clear to you about terminating decimal expansion and non-terminating decimal expansion. So if any decimal expansion is given to you, or if you are asked to convert a fraction into equivalent decimal expansion, I hope you will be able to solve this type of sums. Okay, so this is all about here. Just by we are doing the long division method, we are doing the division method, and we are finding out or identifying whether the fraction is, or the equivalent decimal expansion is terminating or non-terminating but repeating. But there are some easy ways of identify a terminating decimal expansion. Means just looking at the fraction, you can say that yes, it is a terminating decimal expansion or it is a non-terminating decimal expansion. So this will be covered in the next class. Okay, so I think this class is the lectures, the class is clear to you, is useful to you. Okay, so if you find this video helpful, please subscribe to LearnGuru Classes, like, share and comment. So thank you very much. Bye bye.